All right, welcome everyone. So this is going to be a short tutorial on setting up Neo4J application or database. It is built in, so you don't need to download any client on your local computer or anything like that. The only thing you need to do is ensure you have access to the internet and sandbox.neo4j.com. If you click on that, if you just go like this here and hit enter, it should show something like this. Hit next if you wish. You can read that. Put whatever you want. Self complete. And there's a bunch of different database. I'm going to use the movies one, and this is also part of. This is a good one for the assignment as well. So you feel free to choose the others, but just hit movies, and at the bottom hit create. And it should take about 10-15 seconds to load it up, depending on the speed of your internet. So after it's done, it will have something like open. So if you hit open, it will open a browser for you. This is your direct link to the URL. And do note that the database um, um, kind of refreshes or resets every few days. So, stuff that you worked on, it goes away in a few days. So make sure that you have access when you need it. So again, if you're working on something, just get it done, get it out of there, and then so forth. So Sandbox automatically resets every few days, right? So you will get an alert. In my case, I'm using my Gmail. So again, once you get here, hit Sandbox login, and it has a bunch of different things. You can actually look into the user interface. There's a lot of good stuff, good learning stuff, but really, it shouldn't be too difficult even without going here. And this is a relatively new language, and it's based on the idea of cipher language or cipher query language or cipher graph language, whatever you want to call it. And the whole idea of Neo4j is the stuff that you see on tables and in some ways on your MongoDB stuff or SQL stuff. This translates into visual representation. So you will see a good visual aspect of it. So first off, you can read up on this, but if you click here on these little green button at the top left, that is your conduit to accessing the database. And this little Neo4j with a home icon means that you're at a Neo4j database. So this is the name of the database that you're on. Um, the graphical database or Neo4j is based on the idea of having a bunch of different nodes, and those nodes are connected with some sort of relationship between them, right? So that is why it is kind of cool to visualize this stuff. It's just a different way of doing things. You may or may not like it, or maybe not be applicable, but I think visualization is something that's pretty cool. So under node labels, you should see that there are two nodes. One is a movie and the person. So if you click on that one, it is going to give you something here. And it looks like it has here, I'm saying, so when you clicked on it, automatically created a query for me. And let's say hit 50 or whatever. It should in theory give you up to 50 movies. Looks like there's not 50 movies, around 38, but you should see a movie. So if you do a little magnifying glass here, looks like there's movie Castaway, Stand By Me, and so forth and so forth. So these movies are nodes in this context, right? These are nodes. And there are 38 of them, and there's no relationship between these nodes. So it kind of makes sense. Looks like the Stand By Me has no relationship with Jerry Maguire or any of these movies out there, right? This number sign, number star 171 is what is it called is a number of entities. So it could be, it is combination of the movies, it combination of different relationships. different nodes and so forth. There's altogether 171 relationship in this one. Okay, so this is already built in database. So if you click this, and if you just click this one here, um, this is a graphical relationship. So you can see JT Walls acted in this. So these are all these guys that acted in this particular movie, right? A Few Good Men is the name of the movie. You can also look at the same information from a table view like this. Look at this, right? All the movies. Also a text view, like this, how you see in Excel sheet, and from a code point of view as well, right? So, so this is going to be your user interface for Neo4j. This little text button is where you would be pushing your code or query, or whatever you want to call it. You can create here, you can update here, you can read here, and you can delete here, right? So this is where you can run, will be running queries. Okay, so this database, the movie database, or people or actor database, whatever you want to call it, but Neo4j calls it movie database, is the one that you will be using for to answer particular questions, and be looking at different query functions or query styles, to look at what are some of the value you can get by looking at the database. However, we also want to look into CRUD function from Neo4j's perspective. So what we can do here is we can totally create a new database and try some of the commands that's out there, right? So again, if you start putting stuff in this database, your database, it's fine. As long as it's not related, it might be a little weird to see, or a little, confusing to see. So we'll just go ahead and create a new database. So let's hit create in the database, and let's call this, test, right? So, create is a function. Creating what? Creating database, and test is the name of the database. So hit play button. And if everything goes well, it will say, it will not give you an error, and it'll say completed. And if there's an error, like, for example, database, and I just put the wrong email and so test, it will give you something of a syntax error, right? So it looks like it worked out, but where is the database? Well, the database, you'll have to go drop down here and go here. So if you create a new database, it actually goes in here. So hit test. And when you hit test, you are now in test database. And how do you know? There's a test and a $sign. So again, if you want to go back to the original movie database, you go to Neo4j. If you want to go to test, you go here. System is something reserved for the system. You can't really do stuff. So, but if you're on Neo4j and you want to go back to test, you hit use test and play. And I think something's off here. Okay, so here, so test, let's try that. Okay, there you go. So I was missing the colon there, right? So we're here. So let's kind of, if you don't want stuff like, if you're writing this and you want to get rid of the window, that's perfectly fine. Hit enter. Okay, so what we're going to do here is we're going to create a bunch of different nodes and bunch of different connections to see how we can actually design database in Neo4j. So the topic of everyone is the housing, right? Housing this, housing that. The challenge is, what we can do here is we can think about Toronto housing, and we can create a bunch of different houses, and we can see if we can somehow establish a relationship between different houses. Okay, so the function to create a node is always going to be create, and we can, you can, I don't think it is case sensitive, but always you can it is not case sensitive. So when you do create and hit this, you need to put a bunch of attributes within those open and close bracket, right? So for example, I'm just going to paste the code I have here. I am going to create a house. So I call the label house. You can call it anything. You can call it unit. You can call it whatever you want. And within those house node, within this big, label, um, I'm creating a node called house one. House is a label, the designation, and house one is a node. Um, and then within that house one, we can have different attributes, right? So typically, if you are using Excel, you would have a relational database, something like this, and something like this. And you would have 1, 2, 3, and then address, bedroom, and so forth, right? But this one, it's a little structured differently. And also, we know the advantage and disadvantage of doing this, and so forth. So let's hit play button here, and no errors, so something was created, right? So if you can see it here, you can look at the code, like, this was what it was required to create this little outcome, and the table information is also here. Great, so we create one. So how do we know this database is starting to get populated? The house showed up, the node showed up, the node's label showed up. So if you hit star, and if you want to hit graph, looks like something showed up here. That's excellent, right? And then you can just do table, and then text, and you can find different information there. Let's try to create a bunch of different houses because we want to establish relationships. So I'm doing the same thing. You can create house two, and the rest of the information is going to be different for every house. So let's hit enter, and let's create one more house. Okay, you can try it out yourself. You don't need all the information. All you could do is like some attribute, and that's perfectly fine. Or you could not even have this, and it would be perfectly fine. Okay, so hit play, and again, like, you can just X this, and if you hit the star, and now there should be 3 bubbles. In other words, you have 3 nodes. But the nodes don't have a relationship between these things, right? So the nodes are like not related at all, right? What's the point if they're not related? Because the database somehow should show a relationship. That is the beauty of having a database, is you can extract different kind of relationship. But typically, the one you can think about a lot of different things. Utility, you can think about um, internet provider, and literally everything to connect. But I am thinking one thing that I can use to connect these 3 things is municipal taxes or municipality. So everyone reports to Toronto. So if these are all houses in Toronto, I'll say these all report to this guy here, municipality, and I want to create a node based on that one. So again, you can call it anything. You can call it MUNC, whatever you want. But let's create municipality and then hit the node, right? So something happened here again. So if you go back and if you click here, now you see Toronto municipal stuff. Okay. You notice that if I did name, it allowed me to create some sort of naming convention for that, right? Or like, the label as opposed to 2-1. So, you can always go back and change it around if you can do the same thing. So still, we don't have relationship. So, if you look at the relationship types, we don't know how it's connected. So we think, we can create a relationship, something called all of these houses report their taxes to Toronto Municipal Party, or to the body, right? The main body. So how do we do that? We can create a code. So essentially, this is something called match. Matching is essentially filtering. So saying that take house one. I can't tell from the label, but one of these houses, I think this is the one. Take house one and take the municipality here, establish, and create house one as directional relationship to municipality. In other words, ensure that house is reporting to municipality. In that sense, we call it a directed relationship, right? A marriage is a mutual connection. Housing reporting to municipality, student reporting to university, those are directed relationship. or student school providing education to student. That would be a what do you call it, a direct relationship. Okay, so let's hit that play button here. And once we hit the play button, we should get an idea of what's going on here. And if you look, do X and X and X, and if you refresh it, now you should see that this house is now reporting to municipality. Okay, so that's good. So we have one relationship. And if you look at the relationship types, it has reports to. I mean, you could call this anything really, right? So if you wanted to like change the name, you feel free. Okay, so this is something that is not a part of the coding, but it's just something that you established. I'm going to do the same coding for both of them. So again, house2 reports to municipality, and you can do the like multiple codes in one shot as well. So here I'm just going to do same thing. I'm repeating and changing the variables, house3, 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 and so forth, and hit play. Okay, something is up here, right? So let's do one at a time. Sometimes if you run into codes, one at a time is better. So let's hit play. Looks like it's okay. And let's hit the second one. And then hopefully it works. Looks like it works. So I guess, something went up there. So you can always, always delete and restart again. So let's hit the start button here. Beautiful. So it looks like everything is reporting to Toronto municipality. So what we did here in this exercise is we created nodes and created relationship. Now, you can have a different relationship too, right? So you can have a relationship between 2 and 4, 4 and 3, and 4 and 2. Like, it depends, right? Like life's quite complex. It's not just one-to-one relationship. It's one to many, many to many, that kind of stuff, right? But at this very least, it should allow you. Again, you can find this information on table, right? And also you can find this on text and the code to develop it as well. So just to kind of give you an idea. If you notice that every time I'm hitting this, it is yielding some sort of syntax. So essentially match every n in bracket n means everything and return everything and select 25. So essentially what this means is like select everything from table and limit it to 25. That's what it means. Okay. All right. So let's go to the read function of it. Like we want to know the read function, right? So let's try to see, match all houses, right? So match, and let's do house and house, and we'll, oops, sorry. So a match house, and you can hit tab, and let's do return house. Okay, so let's see if this works. So if you notice my code, this is not what I wanted. So match house and house, return house. So I'm just creating a variable here. You can literally call this anything. So you can call it n and then return, and it should yield the same thing. So put everything in house in this little variable and return n. That's what it's saying. Okay, so it's just giving you the same thing. And you could just do this and you could do this and you'll be fine, right? So again, if you wanted to change, let's do match, so have some condition where house dot bed. Remember, like the beauty about this is that you can actually sub address stuff, right? So meaning house dot address. So let's do house dot address. So when you do house dot address, it means it's pointing to this one, or let's say not address but room, bedroom, just for simplicity, right? Greater than, let's say 3, and return house. So there are three parts to the code, like find everything house, where house and bedroom says greater than 3, and return house. So hit next, and something is not working here. So what is happening here? Oh, here. So it has to be n, remember? So this is what you have to do. Return n. So I'm using different variables, it's a problem. Okay, so if you want to use house here, make sure this house is also here, and also here. So don't make a mistake like that. So once again, we're aliasing house as n, where n dot bedroom. So you could essentially write it as n dot bedroom is returning. And just a cleaner code. So make sure, don't make the mistake I did is say something here and say totally different somewhere else. You can also download this stuff if you here export at CSV. Boom, it will export it. Like we can just open the file if you wish, and it'll give you the information. And if you wanted to put it on some sort of different structure, that's also fine. But what this query is telling me is there's only one house that has more than 3 bedrooms. The rest of them look like it's 3 or less. Okay. So another query we can do is between, right? So where n bedrooms are greater than 2 and n dot bedrooms are, let's say, less than 3, let's say. Okay, hit next. And again, I am hitting some issues here, and definitely something is up. Okay, so match and house and bedrooms. So let's start with this one here, and then we do one at a time troubleshooting. So n, boom, something changed here. And I know, so return n. So looks this will work. And I think I had deleted and dot bedrooms tab is less than 3. Okay, so you return n. So if there is nothing, it will not yield. So there's no such thing that has between 2 to 3 bedrooms. So it looks like so if I did 4, in theory it should appear something. So what in the earlier sequence, what I was doing is I was missing this part. So all the time, if you do this and something's happening, it is explicitly telling you must be a return clause or update clause. It's telling you something. It has to be a return is like enter almost, right? Okay. So you can try different queries. Try queries about a bunch of different homes, or you try to add more relationships and so forth. So that is what you call read function. So we did create, we did read. Now we can also do something update. How do we update information? Let's go back and look at the houses, and it looks like the houses prices are 50,000, 60,000, and 400,000. Let's say there was a big recession and we need to change the house. So same idea. A match is your match, right? So it's match is like try to find out. So you always start with comment called match, right? So match. So in this case, we're trying to update the housing price, house in house. So and where let's look at house and dot, like let's try to fix the price, hit enter. So let's try to find a house that is 50,000. I think there was something like that. And after we find that, let's set it to $5. Let's say everything went down the hill. So it looks like it worked. And let's go back to the house here. And if you notice, it went to 5. Now you can try that for address. Make sure when you do address, you have it in quotation and so forth, right? So again, yeah, let's try the housing thing. So you can always manipulate this code here, and let's say where a house dot address equals 123 Main Street is what I saw, and do set house dot address. So make sure the variables are equals. Let's do Bond Street. This is for fun. Okay, so Okay, so something happened here and looks like this was updated. Okay. So specifically it tries to find that particular house and does it. Okay. Um, here's a trick question. What if the housing prices were the same? How would you resolve that? Right? How would you resolve it? If they both had 50,000, which one would get updated? So something for you to think about. I'll let you think about that. So last one, we can also delete the function, right? So delete, let's say we want to delete something that was built in, let's say, 1990, because it is, looks like it is, or 1985, because it looks a little older, right? So again, match and house again, and where house dot year, the built, it's going to show up. So hit enter, is 1985, or equals anything built before 1990, let's say, in this case, should be deleted. So hit run, and it did not, well, because I missed one thing again, which is delete house. So always it, right? So it is always like, I'm only looking at conditions here. So hit enter. So what is it telling you is that it's complaining that there's a relationship that needs to be deleted first. So see, that's the beauty and the curse of this, is that if you notice, if you delete something, the relationship will be stranded, right? So although this command is perfectly fine, it could not be deleted, right? So let's go back and look at the house, and let's look at the thing. So it looks like we want to delete this, which is house ID 3. Okay. And if you want to delete this, what we can do is we can detach it. Okay. So what detach does is it ensures that the relationship is um, non-existent. So we can actually, there's like, it allows us to not accidentally delete data, right? So let's do house, and like what we can find is a house ID equals 1, and let's do detach delete house. Let's see if this works, and let's run. Okay, so it looks like it worked, because what we explicitly said is make sure you go to house, take the house one ID, oops, house one ID, and detach delete house. So it, in theory, should only have 2 houses now. So in this case, we explicitly deleted the house ID 1, right? If you wanted to do for 2, same thing. Okay. In this case, it did not delete it, but yeah. So that is how you delete it. The point is you have to detach it first. Okay. So, oops, sorry. Okay, here we go. So essentially, there are only 2 units remaining here. Okay, so that is some of the things that you can do. You get an idea. You can always download stuff. You can also look at different ways. So it just gives you a visual representation. Try it out on your Neo4j, try different things. If you make a mistake, you can always reset the password. All right, thanks so much.